Hello, all. In this series, we will be covering the theory of consumer choice. This would be a three-part series where we'll be taking a look at budget lines, indifference curves, and how a consumer chooses the optimal bundle for consumption. Now, this is a beginner friendly series, so even if you do not have any prior experience in economics, you will be just fine. So, let's get into the video. Today, I'll be covering the first part in the series, that is the budget lines. Now, a consumer choice depends upon a lot of things, including their tastes, their preferences regarding the alternatives available, the prices of goods, the income of consumers, etc. The prices of goods that a consumer consumes and the income of the consumer, both these factors greatly affect the decision making of a consumer. And this interaction, it is encapsulated by the concept of budget lines. For simplicity, we are assuming that a consumer is consuming only two goods, good X1 and good X2. This would be our consumption bundle. Now, this may seem like a simplification, but you can look at it like this. I am a consumer who is consuming two goods, apples or good X1, and all the other goods that are not apples or good X2. So, good X2 is a set of all the goods that I as a consumer am consuming, and these goods are not apples. So, we can say that this assumption, though quite simple, is not as simple as it seems. Now, let us assume that the price of good X1 is P1 and price of good X2 is P2. We'll denote the income of the consumer as M. Income is how much the consumer can spend on both the goods. The budget constraint would be such that the total that consumer spends on both the goods, it should either be less than or it should be equal to the income that the consumer has. Mathematically, thus, P1 into X1 plus P2 into X2 should be less than or equal to M. Now, P1 into X1 is the amount of money the consumer spends on good X1, and P2 into X2 is the amount of money that the consumer spends on good X2. All the bundles, that is, the combinations of X1 and X2, that satisfy this budget constraint, they make the budget set. Now, what is a budget line? Budget line can be seen as a subset? No, actually, budget line is a subset of the budget set. It's a graphical representation of all the bundles, that is, all the values of X1 and X2 that exactly cause the income of the consumer. So, the equation of budget set can be modified to form the equation of budget line, and it will look something like this. P1 into X1 plus P2 into X2 should be equal to M. Any guesses what this line might look like? Well, to know what something looks like, we need to know three things. What are the intercepts and what is the slope? Here we will represent good X1 by the x-axis and X2 by the y-axis. So for the horizontal intercept of the budget line, X2 will be equal to 0. Why is that so? Because at that point, the consumer is only consuming good X1. That is, the consumer is only consuming good X1 at the x-axis. So our budget equation would be like this. P1 into X1 plus P2 into 0, that should be equal to M. In other words, X1 would be equal to M upon P1. Now, this is also the maximum of good X1 that the consumer can consume with the given income M. Similarly, to find the vertical intercept, we'll do a similar thing by assuming that x1 is equal to 0. That will give us x2 equal to m upon p2. And this is the maximum of good x2 that the consumer can consume. Now let's look at the slope, but before that, let's remember the mathematical equation of a line with two axes x and y. The mathematical equation of a line is y is equal to a into x plus b, where a would be our slope and b would be our intercept. So what we are going to do right now is that we are going to transform our budget line into something that looks similar to the mathematical equation of a line. So we know that our budget line is p1 into x1 plus p2 into x2 is equal to m. We are going to divide the entire equation by p2, which will give us p1 upon p2 into x1 plus x2 is equal to m upon p2. Now taking the term with x1 on the other side, we will have m minus p1 upon p2 into x1 is equal to x2. From this equation, we can clearly see that the slope of the budget line would be minus of p1 by p2. So we have the three things, and we can therefore draw what a budget line will look like. We have intercept for x-axis as m by p1. We have intercept for y-axis as m by p2. And we have the slope as p1 and by p2, and this is negative. Since the slope is negative, what we'll have is a downward sloping budget line, and this minus of p1 by p2 shows the rate at which the consumer can substitute good 1 for good 2. So now we have established what a budget line looks like. So now let's just see how it responds to changes in prices of the commodities that the consumer consumes and the income of the consumer. The first case that we'll be taking is when the income changes but the prices of the good remain the same. If we look at this logically, with more income, the consumer can buy more of both goods than they could have before. So technically we should witness a rightward shift of the budget line. Now see if that also happens mathematically. So if income, we are assuming that if income changes or increases from m to m dash, then our new budget line would be such that m dash should be equal to p1 x1 plus p2 x2. And our new intercepts would therefore be equal to m dash by p1 and m dash by p2. Now we've used the same methodology as before for finding these intercepts. The slope similarly would be m dash by p2 minus p1 by p2 into x1, which should be equal to x2. So the slope here, which would be minus p1 by p2, it has remained unchanged. Thus we can also mathematically, we have proved that our budget line will shift outwards, and this shift would be parallel in nature. That is, the slopes of both the lines would be changed. It won't be changed, it will be the same. The inverse will hold true if income falls. So if the income falls, the budget line will shift parallelly, but that shift would be inwards. Or you could say a leftward shift. Here we have to remember that the intercepts for both the axes, they will change, yet the slope of the line, it will remain unchanged. Now case 2 would be if price of one good changes while the income remains constant. If this happens, what we'll witness is a rotation of the budget line around the intercept of the good whose price has remained unchanged. For example, if P1 increases, our budget line will rotate inwards. Since the consumer can buy less of good one now with the given income that he has, which is M, and that income M has remained unchanged while the price of good has increased. Similarly, if P1 falls, the opposite will happen. Here, only the intercept of the good whose price has changed will change. With this, I'll end the video, and if you have any questions, leave a comment. I'll try to answer. I hope I was able to help someone out with this video today, and bye bye.